Okay, good day, everyone. Thank you for joining us for this webinar presentation. My name is John Clements, and I'm the technical lead for the Homeland Defense and Security Information Analysis Center, or HDIAC, one of three IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, or DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. HDIAC supports those working in the Homeland Defense and security domains of DoD research and engineering. We do this by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. We provide research and analysis services and help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We provide a technical inquiry service in which government researchers, including contractors, can receive 4 free hours of technical research. To learn more, go to hdiac.org and click on the technical inquiries icon. We hope you enjoy this webinar and that it serves as a catalyst for community collaboration and improved DoD Homeland Defense and Security research. Before we begin, I'll note a couple of administrative items. First, if you're dialed in by phone and would like a copy of the slides, they were posted to the HDIAC webinar announcement. You can go to hdiac.org/webinars and find today's webinar. When you click on it at the bottom of the announcement, it will say view webinar slides here. You'll be able to download them from there. Second, all participants are muted, but you can chat with the presenters and moderators using the chat box to the left. However, if you would like to pose a question for the Q&A session at the end, please use the audience questions tool at the top center of your screen. It is the icon that looks like a chat bubble with a question mark next to the emoji. At the end of the presentation, I'll go over the Q&A, and for the benefit of those on the phone, I'll read the question out loud for the answer. If you have a technical issue during the presentation, or if you have colleagues who missed it, have no fear. The full presentation will be available online. Check back at the HDIAC website. Once the webinar is posted, the Go to Webinar button will take you to the YouTube link. And here's where I normally would introduce the webinar presenter, but today's webinar presenter is myself. Again, I'm John Clements. I'm the technical lead for the Homeland Defense and Security Information Analysis Center. I have conducted research in the counter-UAS space, particularly as it pertains to the Homeland, as opposed to other DoD applications that may be in contingency operations or overseas with another host nation. So I just wanted to synthesize some of what I had learned over the course of some of the research that I had done and some of the conferences that I've attended, and put that out to the community to really inform people of some of the issues that are out there and some of the technologies that may be solutions, but there's multiple issues and legal constraints that the Homeland Defense and Homeland Security enterprise faces that others may not so much, especially around the DoD. So with that, I'll go ahead and I'll get started. Move forward. So just a real quick classification of the UAS. I haven't sit on many briefings that don't go over this at some level, but UASs can range anything from a micro UAS that can fit in the palm of your hand, all the way up to a large unmanned aerial system, which can be carry a weapons payload or carry a larger payload of supplies, travel at high speeds, and uh, deliver supplies of weapons and munitions on a target. So this is just how they are grouped. You have group 1 through 5, group 1 being the smallest, group 5 being the largest. Many people on this call are probably familiar with this, so I didn't want to beat it up. I wanted to bring it out as some of the technologies we might discuss later. If you look deeper into them, they'll talk about you know that they're viable for detecting group 1 and 2 UAS or things like that. We'll go over real quick some of the threat trends that I've seen. This slide here is just a real quick snapshot of several uh, news headlines that I came across while I was doing this research. Almost all except for the one is from this year. So, a DC airport incident exposes gaps in counter drone authorities. That was something from Bloomberg government, and that's the indicative of what we're going to go over today, what we're going to look at. So, in addition to the official categories, kind of break this down from the threat perspective into large UAS, capable of carrying long range weapons, as I've already said, used also for ISR, intelligence, surveillance, and reconnaissance. You have small UAS, such as the DJI Matrix 300, and dozens of others, probably hundreds of others, as well as I put on there the Helios 2, which only 3.2 pounds, designed to fly indoors, down to micro UAS, like I said earlier, could fit in the palm of your hand. This is also what most hobbyists are typically going to build. It would be a small UAS, a lot of times a quadcopter, something like that, which can be built, which also presents other issues. The use of swarms. You can see this online, how swarms are being used for multiple purposes. Um, one thing that I saw, I don't if anybody's seen the videos, I believe it's in Hong Kong, and there's actual videos of lit up drones, UAS, being used to do a light show in the sky, and it's really cool looking. It's really amazing. But just picture that same kind of technology that is putting these drones in a shape that is identifiable from the ground, being used for nefarious purpose. And then that picture on the right, if you are involved in the Seaburn enterprise, the idea of farm spraying applications would make the hairs on the back of your neck stand up a little bit. The uh, Even using a sprayer type of drone filled with something that's completely inert, completely benign to human contact or animal contact, could have grave consequences of creating panic among a crowd. I know if I was in a crowd of people and a drone flew overhead and sprayed something on me, that's the last place I'd want to be, and I would try to get out of there. That could create some panic. Um, some market research that I came across showed an increase in agriculture drone market from $200 million in 2020 to over $2 billion in 2030. Um, and that's just an estimate. Could be much higher than that. I feel like it very well could be. So some of the things that is making the drones more and more ubiquitous and more difficult to counter is their availability and speed. Um, as I said, hobbyists can go out and build a drone. Um, there's there's drones of various levels of sophistication available for commercial purchase. Um, and in addition, we have 3D printing now, so people are 3D printing drones and parts of drones and things like that. Where we just even with some of the sensors that are out there, might not pick it up as a drone because it's not giving off the typical drone signature. One thing I came across actually fairly recently, that I wasn't aware of prior to getting into this research was hobby jets. And there's actually a video which wouldn't be able to show you here, but a YouTube video I came across of somebody launching a jet that they had built. It looked somewhat like the V-wing stealth type of aircraft, but it was jet powered, traveled at over 100 miles an hour on the video, and he took it in and out of cloud cover, and it was amazing how fast and how tight it could turn. And that is somebody who went out and bought parts at a hobby shop. So I found a couple of the model jet engines online, made 370 to $460 for a larger model one, about $2,500, which depending on your means and what you want to accomplish, $2,400 is not expensive to for something that can go that fast. So communications is another thing that is increasing with drones and in size and scope and its potential. Um, Longer range communications allowing for longer flights. Onboard guidance systems can be used, um, and in this case, that would allow the drone to guide itself and have no connection link back to a ground operator, which then could allow that drone to be pre-programmed, and trying to hack or jam any type of signal would become useless. There's also drones that are capable of using 5G communications and would be able to travel well beyond the visual line of sight of the operator, possibly for hundreds of miles. As long as it stayed in contact with the 5G network, it could continue going. As far as one person referenced Orlando to Miami to me. It could go from Orlando to Miami, as long as it had the battery power to do so, without ever losing a 5G connection, and could uh, continue on that flight path. And that's just something that, again, a lot of these things are available to the public now that just didn't even exist before. So this is kind of a little bit of an eye chart. Just goes over drones being used as cyber weapons, but also drones being cyber attack targets. So if you employ drones in your organization, they're also a target of cyber attacks. And then there's drones that are operated by DHS. This was from a DHS report, or an ally, another government agency. Um, and there's also those drones that are adversarial to the U.S. mission. So there's multiple ways to attack this problem, but some will have some legal considerations when it comes to, especially trying to mitigate drones that may have bad intentions. So some more emerging improvements here. Batteries. Um, it's kind of its own whole subset of technology is battery tech. Now with the push to decarbonize the electrical grid, things like that, coming up with a way of storing electricity is becoming an increasing focus of research, especially among like the Department of Energy national labs. And batteries are just becoming increasingly lighter, smaller, and storing more energy. Another consideration with the current batteries is that lithium ion batteries can actually pose a hazmat risk. So, if you were to take down a drone or a drone crash somewhere, and it was powered by lithium ion batteries, especially if a fire resulted or if it crashed into a fire, you now have a potential hazmat situation. So, it's just another consideration when dealing with drones. I will point out I tend to use those words interchangeably. Drone, UAS for unmanned aerial system, UAV for unmanned aerial vehicle. Um, for the purpose of this briefing, I may interchange them, and I do apologize if there's a large difference in your community, but hopefully everybody gets understands what I'm getting at when I refer to these different items. So more emerging improvements with the drones is the size, weight, and power. Power kind of related to batteries, but can also be related to the type of engine that's being used, or type of motor, I guess would be the better way of saying it, that can be used. But in regards to weight, as we said, there's a lot of 3D printing technology out there now that can print things in different materials that was never not even imagined 20 years ago, 10 years ago, even. Um, there is research out there to make um, drone blades uh, lighter and sturdier. So you have a drone which maybe weighs only 7 pounds now that can be brought down to 6.5 pounds. And you say half a pound isn't that much, but when it's a half a pound out of seven, that's you know we're talking four, almost somewhere around 4% of its body weight. Now it can go much farther with the same exact battery. So if you then take the previous slide on battery tech, and you have a better battery now, you've extended it that much farther. So things are constantly changing and evolving in this with this threat. So some counter UAS methodology we'll go over, both from the Department of Defense and the Department of Homeland Security. Uh, with the Department of Defense, this is their counter UAS methodology, and again, this generally will apply um, to DoD operations overseas or DoD operations in the homeland that have the authority to mitigate drones. But there are some similarities between this and the Department of Homeland Security methodology, and you know when we say detect here, that is just merely detecting that there is a drone in the vicinity, somewhere in the area, um, and it's going to give you a general idea of where that drone is. The identification is the process of determining the friendly or hostile character of an unknown detected contact. Um, so this, especially overseas or in a contingency operation, is a process of determining which nation is responsible for that detected drone. Um, for deterrence, that is the prevent action by the existence of a credible threat of unacceptable counteraction. So, in other words, just like nuclear deterrence is the threat of you know don't fire your nukes because we have the nukes that we'll fire. Deterrence is the action of don't bring your drone any closer or else we will defeat it. And then that brings you to the fourth and final defeat if necessary. If deterrence fails, then you defeat the drone. And again, within the homeland, that has its own constrictions. However, um, DoD tends to operate in multiple areas, so they do operate in the homeland. Um, some of the good and the bad is that the burden of detecting and identifying systems in the vicinity of U.S. forces in the homeland is still the responsibility of the individual installation commander. Um, and that, depending on the installation, they may or may not have certain authorities they need to um, defeat a drone. Um, Also have to call on the mind if they do have these technologies and they do have the authorities. Harmful RF, laser, microwave does have the potential to affect civilians or property. So you just can't go out there and fire at a drone that they don't like with some new high tech directed energy weapon and always expect that there's going to be no collateral damage. When operating in a host nation, um, DoD has to be cognizant of that host nation's rules and regulations regarding drones. Um, so the local commander's authority may vary by that location. So there's a lot of education that has to go into every time you set foot in another country. And then obviously in contingency operations, it's the least restrictive, but it's also the most dangerous because those drones are more potential. There's more potential of drones being weaponized. Um, U.S. and partners will also employ UAS, creating a very highly congested but lesser controlled air domain. So it is more important that those drone detection systems are on point with identifying friend or foe, and um, and being able to detect and track them. So now we'll go into a little bit of the Department of Homeland Security's methodology, which is very similar, but in their parlance, there's a detection, and then there's locating and tracking, and which is a little bit different. Classifying and identifying, which have some nuances, and then mitigating. So with that, this comes right out of the Counter UAS Tech Guide that is produced by the Department of Homeland Security. So detection is simply a declaration that, just like with the DoD, that UAS is in the presence of a sensor. So some sensors, some systems may report any object as a detection. So you get birds, commercial aircraft, you know, anything that is in the air. A kite could potentially be a detection in this case. A lot of the drone technology, which we'll look at a little bit later, will um, claim to minimize false positives, and that's what they're talking about. Using AI and ML to get rid of those detections of birds and other objects, um, to to reduce false positives and increase the confidence that what you're detecting is actually a drone. So the location and track, very similar terms, or very similar ideas. Location is just kind of a pinpoint of where the drone is. A track is a compilation of location reports over a period of time. So location is a point on a map. Track is kind of a line on a map. Um, so on some sort of common operating picture, that's what you're going to see with a track is kind of a line of previous locations, and perhaps you may get a line or an arrow that's pointing its future location or estimated future location. So classification, identification, often used interchangeably. It's just a matter of knowing which one to use when. So classification is the assignment by the counter UAS technology or an operator of potential target UAS to a high level category such as type or the group like 1 through 5 that we discussed earlier. Um, some technology can get down to the manufacturer, and even the model, for known manufacturers and models. Again, the limitation there is we have these um, hobbyists, or might not be hobbyists, could be somebody doing it for a nefarious purpose that can build and create manufacture a drone, in their garage somewhere. The identification is the assignment of by the UAS technology to a more specific name or category, such as the physical address of its modem or the exact make and model. So, classification would be the manufacturer. Identification would be the exact make and model. Basically, identification is a more narrow, precise classification, if that makes sense. And finally, mitigate, which can be used interchangeably with negate, interdict, neutralize. It just describes the method of mitigating or reducing the threat posed by the UAS. Um, could be using RF or GPS jamming, spoofing or hijacking, and kinetic attack. But these methods are not legal for any entity other than DHS, DOJ, the Department of Justice, DOD, or the DOE, the Department of Energy. And that comes from National Defense Authorization Acts in fiscal year, I believe it's 2017 and 2018 are the ones that identify those authorities. Um, so very important to understand. And just because you're a DoD person doesn't necessarily give you the automatic um, ability and authority to mitigate the drone some way. Uh, you have to um, still have that authority vested in you by your organization. So just because I'm a soldier out there on guard post and a drone comes near me and I don't like it, doesn't mean I can take my rifle and shoot it. That's not how that works. You have to be trained and specially equipped and receive the authority, just like any other legal authority. Excuse me, skip that. So we'll talk about some of these legal considerations. I keep bringing up the legal authority but what governs that? What am I talking about? So I'm talking about regulatory considerations for the most part. First of all, the FAA, number one, they define a drone as an aircraft. Basically, a drone, as far as the FAA sees it, is the same as a commercial airline, just less the people. So taking a drone out of the sky is the same, as far as the FAA is concerned, as taking down an airliner or cargo aircraft or anything. Um, The drones are governed by Part 107 of the CFR. For commercial use requires a license for a drone, but there is a recreational use carve out. With recreational use, most people can use a drone pretty freely. They do still have to be mindful of restricted flight areas around airports or temporary flight restrictions for different reasons. They're supposed to register their drones online, and there's an optional right now uh, safety test for the drones called Trust. Um, Lastly, I'll point out too that the airspace above your property is not necessarily um, that is still governed by the FAA. It is not necessarily owned by the homeowner. So there's a lot of instances in which homeowners, maybe there's a police drone or maybe a some sort of pipeline inspection drone or something like that that is flying, and the homeowners feel like that it is a trespass and they try to take down the drone, and that's technically not legal as well. So for the FCC, the Federal Communications Commission, jammers are illegal. You cannot operate something that is going to jam signals. A private citizen does not have that authority. It can only be used by federal law enforcement. Again, there it is, the 2017 and 2018 National Defense Authorization Act. They may interfere with others operating on the same frequency bands. And what frequency bands do drones operate on? Well, a lot of the remotes for drones use those 2.4 and 5 gigahertz frequency bands that tons of other electronics operate on, including emergency communications. So that is the primary reason why you can't just jam a drone. You may be disrupting other emergency communications and other important communications in the area. So, state and local law enforcement, I really truly, in my capacity, can't speak for um, what state and local law enforcement can be, but what I can relay some messages that was given to me during the drone assessment and response tactics course, which is a FEMA provided course, which I highly recommend for anybody, any local law enforcement, state law enforcement. If you attend the resident course, it is even your travel is paid for. So I would be happy to answer more questions about that. And then HDIAC is actually hosting a course October 4th and 5th, which will be virtual. Uh, I Even though we're hosting that virtual course, I think you get a little more out of being there in person. So I would highly recommend anybody on this call that has an interest to go look at, Google that course or look it up on HDIAC.org and find out more information. But to be effective, state and local laws can't really regulate the drone itself because that is in federal airspace. So the number one tactic is to locate the operators if a UAS is operating illegally. Um, and oftentimes the best way you can do that is just to follow the drone back to where it lands. It's normally going to land back where the operator is. Luckily, the vast majority of drone encounters is just somebody who didn't know or didn't care that they were flying illegally. Um, so with that, if you communicate with local community-based organizations, some local drone flying clubs regarding appropriate drone use, that is a good best practice for local law enforcement to because those people, they don't want more drone laws to come clamping down on them, so they will to some degree police their own. And again, make sure your means to detect, identify, and track drones are legal based on what we've already discussed. Another thing that it can do is to work with local lawmakers and district attorneys to limit the access of drone operators. So you can restrict the operator. So uh, one thing you can do is limit. Nobody can operate a drone from these county parks, let's say, and there's a line of sight requirement that is an FAA requirement for drone operators to have visual line of sight to their drone, which so that limits the drone's flight area. So um, there's obviously all kinds of problems with that as well. But somebody could step 1 foot off the park and they could still operate their drone, and it may even cause more problems than it's worth. But it is one possible way of mitigating drone use that you don't want um, taking place in a certain area. So now we'll talk a little bit about the detection technologies that are out there, and there's multiple different types of detection. You have radar, electro-optical, infrared, um, electro-optical and infrared combined, um, acoustic, and now 5G, which is let's see, an interesting technology that DHS is working on later on here. So one of the solutions, Defense Solutions, provides enforced air. Enforced air is the name of the solution. And before I go any further, I'll just put out a quick disclaimer that anything included here is just for informational purposes. Uh, this is not an endorsement by HDIAC or Defense Technical Information Center or the DoD. It's just merely going over some of the things that may be out there, and I pulled a lot of this information just from their websites. So this isn't, I did not do rigorous test and evaluation behind this to bring this to your guys' attention. So Defense Solutions of Force Air, it identifies and locates rogue drones using RF frequency. It'll lock onto that drone signal, and then it's also able to take over the drone communication. So that's not necessarily in line with FCC regulations for local and state law enforcement. So you'd have to be careful of if you're local and state uh, employing this. If you did employ it, you wouldn't be able to take over the drone communications, and then it lands the drones in a pre-designated safe zone. Uh, the next one is the Fordham Technologies TrueView radar. So that one features a very low size, weight, and power. It's less than 15.5 pounds. It only uses 38 watts to power. It has a 360-degree view, and it does offer some AI at the edge, so it sorts out the drones from other noise. And one of the nice things about this is it can be linked together for a contiguous view of um, of an entire area. So that uses some AI ML on the back end to kind of get your view synchronized. So the square head technology Discover, this is an acoustic sensor, and this is kind of neat looking. Has 128 different microphones. This is one of the ones that claims nearly zero false alarms because it's using the acoustic sensor, acoustic signature from the drone to say that this is a drone. So a bird flapping its wings or a large helicopter or aircraft is not going to provide the same signature that a drone will. Uh, Claims to have pinpoint direction accuracy to the target, and it works alone or it can be linked with other C2 systems through an open API that they'll provide. So this one is actually one that looks very promising. Um, Unfortunately, I don't have pricing information or anything on this, but this is something you'd want to look into if you had a need for this kind of technology. The From a company called Kinetic, the Obsidian counter drone system uses 3D radar with high accuracy position and quick refresh. Combines radar with microdoppler, so it's using that microdoppler acoustic technology, combining it with radar to minimize the false alarms, and um, and it continuously updates the 3D position. So that's it's nice that it gives you both the distance to the target, the height of the target, and to give you a very clear picture of where this is, and where this is going. Opt-out accuracy, XRU, HD and thermal imaging, point tilt zoom. That's PTZ. So that one has a long range thermal imager. So it picks up a thermal image based off of a lot of it will become from the battery pack and the motors. It's ruggedized for a harsh environment, and and it has a laser range finder. Some of the limitations with that is that nothing can be in your way, so to speak. If it goes behind a tree or something, you may lose it. Um, because it needs that clear picture, the clear sound, and the clear line of sight for the range, as opposed to a radar position. If you're able to position multiple radars and link them together, it does purport to be very low maintenance as well. And this one is actually sponsored by a DHS SBIR, Small Business Innovation Research Award. And it's called the Urban Canyon Detection, Tracking, and Identification System. This one uses 5G base stations to detect and locate drones. So this is pretty interesting in that it's using existing 5G infrastructure. So the big limitation there is if you don't have 5G infrastructure in your location, you cannot use this drone. But 5G also is being rapidly employed across the nation. So um, you may end up with 5G soon if you don't already have it. It uses millimeter wave frequencies for high target resolution, um, uh, providing better accuracy than X band radars. Um, but again, as I said, it's limited in lower density areas. You need those 5G base stations. Um, but it was it did prove in some testing conducted by DHS to I have a high level of accuracy in picking up drones, and I think this is going to be promising technology, especially in urban areas where 5G is becoming ubiquitous. And then this is in a specific system, just a type of system, a type of potential system that might be out there. Terahertz radar frequency using those 300 gigahertz up to 3000 gigahertz radar frequency. Um, One of the uh, benefits to this is it has the ability to penetrate non-metals, and providing you a very precise, however short range uh, picture of where the drone is. But with some refinements, it is a very promising future technology that is out there. Again, it penetrates that outer plastic skin and reflects off the metallic frame uh, and the motors and things like that. And then VHF and UHF radar, some of the benefits to that is that it's useful for stealth craft. So, um, craft that are trying to fly, quote, under the radar will have a more difficult time dodging a VHF and UHF radar. They can cover much of the sky, and the real nice thing with this is the frequency is low enough that the drone does not detect the radar waves. So, um, that if there is something built into the drone where they fear they detect the detection, then VHF and UHF radar, band radar is a way of getting around that. The big limitation is that it will not necessarily give you a precise location, and the precision of the location varies by system. So, a prime concern now is the integration both between drone detection systems and with drone detection systems and other systems. If you're have some sort of emergency operations center or a, real-time crime center in your location, and you need the drone to be able to be integrated. So DHS is working on coming up with some standards for drone interoperability, and this comes from a counter UAS interoperability analysis data object model layer standards that the Homeland Security Systems Engineering and Development Institute produced. That is an FFRDC, which is operated by the Department of Homeland Security. And so they are trying to, they started pretty high level, but their machine to machine talking standards is cursor on target, TCUT, the tactical counter UAS technologies, and universal command and control, or UC2. Um, the radar data transmission, the all-purpose structured Eurocontrol surveillance information exchange, which is typically what commercial aircraft use. And then the Motion Imagery Standards Board suite of standards for motion imagery metadata. So that comes up with a schema for motion imagery, and utilizing that schema should allow your system to be interoperable with other systems if everybody's using that same schema. So that's some of the findings that they have, and this is a notional architecture that they built. So the main reason I'm showing this is a somewhat complicated architecture, especially for um, local law enforcement, and even most state agencies, and even at the federal level. So um, it's not complicated in the sense that it would be difficult to set up, I think, but I would look at that and say that that is fairly expensive, because they're combining electro-optical and infrared sensors, radars, RF sensors, acoustic sensors, all into this sensoral sensor fusion engine, with you have command and control applications, and that all feeds to a cop. And that sounds great in theory, but that is a lot of equipment to for one specific purpose. So that's going to create challenges, but I think with DHS looking at ways of um, trying to make these systems interoperable, there will be funding, there will be availability to keep these systems, to make them affordable, at least to a degree. So what all this means is, as I said, a fully functional, well-designed counter UAS system. It's going to be expensive. So right now, I fear that what organizations are currently doing is going to be the short-term path forward, and that is basically finding a system that they can afford that works well enough to counter drones. Um, so DHS working on some of these interoperability standards. So hopefully, as we get to the midterm, more organizations, more commercial industry partners are developing counter UAS systems that meet those interoperability standards. And then state, local, tribal, and territorial organizations can work with federal partners for increased CUAS funding. And that's going to be, I think, the way ahead, if I had to guess. So this is just kind of a snapshot of some of the mitigation technologies that are out there. Um, in the interest of time, I'm not going to go over every single one. I already went over a bunch, but some of the ones that are, um, most of these are fielded with the DoD in mind. But just if you wanted to take a look at any of these, we do have a HDIAC, and our partner DSIAC, Defense Systems Information Analysis Center, has reports on some of these, um, that describe them in a little bit of detail, or you can go to old Google search there and look these up and find out how exactly they work. Um, but again, they work in many different ways. Jamming, again, illegal for state and local law enforcement, same as kinetic effects, uh, and spoofing, where you take control of the UAS to C2. Depending on how you do that, that's also going to be limited. And with that, that concludes my presentation. I do welcome any questions from the audience. If you have any questions, I'm also going to take a look. It doesn't look like anybody chatted anything to me, but you can reach me. My email address is there, and my phone number there in the bottom right-hand corner. Or if you want to just remember contact at hdiac.org, you can reach our entire team, and that can help dig deeper into anything that we talked about today. or just about any technical topic you can come up with in the Homeland Defense and Homeland Security arena. Um, I will pause for another minute or two to see if there are any additional questions or any questions at all that come in. All right. Well, nothing seen. I do appreciate everybody that took the time to sit and oop, and listen to the presentation. And I hope that this was at least somewhat helpful to understand the problem set, understand technologies that might be out there, and some of the limitations of that as well. And just get a jump start. Please feel free to reach out to HDIAC if you need additional information. But with that, thank you all very much. I do appreciate the time.